graphing linear functions. So just as a note, before we actually start on the next few sections, make sure you get some graph paper that you can use for sketching and for drawing some graphs. So we're looking first at linear graphs, and we have our slope-intercept form here, our general equation y is equal to mx plus b, where our m is the slope and b is the y-intercept. So by slope we're meaning for every 1 in x we go up whatever our m is in our y, or conversely for our 1 in x we go down by our m in y, whatever that value here is. So here y is equal to 3x minus 4. So our y-intercept here, where we cut through our y-axis, is going to be here at minus 4. And our slope means that for every 1 that we go across, so we go across here to 1, we're going to go up by 3. So up by 3 here, and that will be minus 1. Go across by 1 and up by 3. So 2 and 2, and so on. So the first step in graphing equations is to get a collection of ordered pairs by substituting our x values and determining our corresponding y values. So here we can conveniently do this by using a table of values. So to graph y is equal to x plus 2, we only actually need 2 points to form a line, but we always take 3 points to ensure that the third point is consistent with the other two and we haven't made any mistakes in our substitution. So we generally choose x is equal to 0, 1 and 2 because they are the easiest to use and least likely to cause a mistake. So substituting in y is equal to x plus 2, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. So we get our x values here, and our ordered pairs are 0, 2, 1, 3 and 2, 4 here. So we can plot these on our line here. Our dependent variable always goes on the vertical axis here, and our independent variable always goes on the horizontal. So our graph should look like this one here. So we have some other examples. Our horizontal lines here, y is equal to -2. So here it's always going to be y is equal to -2. This is our point -2 on our y-axis. Our line just continues on that point. And we have our vertical line x here, and there's our y. X is equal to 3. No matter what our y is, our x is 3. So we have exercise 4.7.1. We want to graph the following equations on separate number planes by using tables of values, similar to our example that we went through. So here, for our first example, we have y is equal to x plus 1. So here 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So our x is here 0. Our y is here at 1. So that's our first point there. When x is 1, y is 2. When x is 2, y is 3. So these are our 3 points here, and we can plot our line y is equal to x plus 1. When y is equal to x, when x is 0, y is 0. X is 1, y is 1. X is 2, y is 2. So here we plot our first point here when x is 0 and y is 0. When x is 1, y is also 1 here. When x is 2, y is also 2 here. So we connect our dots here, and we can draw our line here. So y is equal to x. So keep on going with these. We've got y is equal to x minus 1. 0 minus 1 is minus 1. 1 minus 1 is 0. 2 minus 1 is 1. So we plot our points. X is here at 0, y is minus 1. X is 1, y is 0. X is 2, y is 1. And we continue our lines. Y is equal to x minus 1, making sure we label our line here with our equation. y is equal to 2x, 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4 here. So 0 here, x is 1, y is 2, x is 2 and y is 4 here. We draw our line, y is equal to 2x here. So we keep on going. This one's going to be a little bit easier to calculate if we arrange it here. So y is equal to 5 minus x. 5 minus nothing is 5. 5 minus 1 is 4. 5 minus 2 is 3. So when x is 0, y is 5 up here. When x is 1, y is 4. And when x is 2, y is 3. So we continue our line here. X plus y equals 5. So here y is equal to 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. So x is 0, y is 3. X is 1, y is 2. X is 2, y is 1 here. So here y is equal to 3 minus x. Okay, again this one is going to be a bit simpler to work out if we rearrange. So if we move our negative y over here, minus y, here becomes positive y. So y is equal to 2x minus 2. 2 times 0 minus 2 is minus 2. 2 times 1 is 2, minus 2 is 0. 2 times 2 is 4, minus 2 is 2. So 0 minus 2, 1, 0, 2, 2. Our line goes here, whoops, there. And we say, well, 2x minus y minus 2 equals 0. Here we have y is equal to 4. Here's our 4. We just follow this point here. Y is equal to 4. It doesn't matter what our x values are, our y is 4. So here x is minus 2. We don't even need to fill this out, do we? Here is minus 2. X equals minus 2 is this line along here. X is equal to 3. Same thing, a little bit higher up. X is equal to 3. So having worked through these, we might be interested now in sketching lines in a quicker way. So I'll just lift this one up a little bit here. Okay, so one of these methods is the intercept method. So here we're going to extract our values of y from the table by looking only at the graph. So y is 0, x is 0, y is 3. X is 1, y is about 7. X is 2, we've got what, 12. X is 3, 16, 4, 19, 5, 23. So if we use here y is equal to 4x plus 3. Here 0, it will be 3. 4 times 1 is 4 plus 3 is 7. 4 times 2 is 8 plus 3 is 12. 4 times 3 is 12 plus 3 is 15. We're a little bit messy on that one there. 4 times 4 is 16 plus 3 is 19. 4 times 5 is 20 plus 3 is 23. And lastly, we're going to look quickly just at solving simultaneous equations by drawing their graphs here. So what we need to do, our first step, is construct our x and y axis. Our x always on the horizontal, our y always on the vertical. And we need to mark our values of x and y as appropriate along the axes. And we can ensure the values match the graphs to be drawn. So there's no point drawing up to 20 if it's only valid between 1 and 2, and so on. So our step 3, we plot one linear equation using a number of x values, and then we draw a straight line. We repeat this for our second linear equation. So we only need to plot 2 or 3 points, as the line to be drawn is going to be straight. then we check that we've chosen the correct range of x values so that our actual lines do cross somewhere. We find a point where they cross. If we have here one line and they don't cross, we need to extend our range so that we can get this point to move down into actually touching. We note where our lines intersect and we can read off the values of x and y. So if we look at the value here on our example, so here we've got y is equal to 3x minus 9. So we've put these points here and we've plotted our line. Here y is equal to negative x on 2 minus 2 here. Plot our points and draw the line. This is here our point of intersection, here at 2, negative 3 here. And we can check this by solving two equations by substitution. So here we know, well, y is equal to 3x minus 9 and y is equal to negative x on 2 minus 2 here. So 3x plus x on 2 is equal to minus 2 plus 9 here. So if we want to get rid of this divide by 2 in here, so we're going to say, well, 6x plus x is equal to here, and we've got what 7 multiplied by 2 is 14. 7x is equal to 14. X is equal to 14 divided by 7 is 2. So this is our x is equal to 2. And we substitute into one of our equations. Y is 3x minus 9. Y is equal to 3 times 2 is 6 minus 9 gives us minus 3. And this is our y value here. So we end up with our coordinates of 2, negative 3, which is what we found from our graph. So if we look at another example here, so here we have y is equal to 4x here, and here y is equal to negative 3x plus 7. So this is the point here where they meet. So here at 4 and 1 is where they meet. So our x is 1 and our y is 4 here. And if we substitute in, well, we're saying, well, y is equal to y. 4x is equal to minus 3x plus 7. 4x plus 3x equals 7. 7x is equal to 7. X is equal to 1. And this is our x value here. Then y is equal to 4x. Try and always use the easier one. 4 times 1 is equal to 4. And that's our y here. So from this we get 1 and 4 to be our point of intersection here.